Beloved students, in this video lecture we are going to discuss about another simple experiment in this AC machines laboratory series, that is the load test on a given single phase induction motor. So the objective is to get the performance characteristics of the given single phase induction motor by conducting the load test. And this is a circuit diagram for conducting load test on a single phase induction motor. This single phase induction motor is made up of a squirrel cage rotor, and this represents the squirrel cage rotor, and there are two windings here. So M1 and M2 you call it as the main winding, and A1 A2 you call it as the auxiliary winding. So this you call it as the starting capacitor, and you call it as the running capacitor. And we know that the single phase induction motor is not a self-starting one by its performance, by its nature itself, and hence we need a main flux as well as an auxiliary flux to get a revolving speed, or to develop the necessary torque to make the motor a self-starting one by making the rotor to rotate. So at the time of starting, both the main field and auxiliary field will be active. So when the machine starts rotating, this centrifugal switch disconnects the auxiliary winding, and the running capacitance alone is going to be there. So this is starting and this is running to improve the power factor. Okay, coming to the procedure, how to do this experiment. Give the connection as per the circuit diagram. Close the switch, and now close the switch. Now the machine starts rotating. So what is happening now? So the machine is now running at a no load condition. Okay, now so under no load condition, measure the line current, line voltage, wattmeter reading, and speed, and of course so the load which should be always 0, and if it is not so, you have to take it as an error value. So, and after taking the no load reading, so you have to add the load by slowly tightening this brake drum and thereby tightening the rotor. A mechanical load is given to the machine, and for each addition of the load you have to take another set of these readings. So you have to repeat the process until you reach the rated current and current slightly above the rated current. So once the readings are taken, switch off the connection, release the load, bring back its original condition, and switch off the motor by opening the DPSTS. So do the calculation to find this efficiency, slip, power factor, and everything. So after getting, you have to draw the performance characteristics curve using the obtained results. So compare the results for various load conditions, how the efficiency changes, that means how the efficiency changes with respect to the addition of load, and how the torque changes with the addition of load, how the slip changes with the addition of load, and also draw the torque versus slip characteristics and give into your interpretation based on the shape of the curve and on the data that is available in your tabular column. So once everything is over, it is corrected and give it as a report at the end of this class. Okay, thank you.